Is the one,
Is it what?
is the one you have?
Nope. Nope. Yep. It's just there's a so the first nine problems I should see a significant improvement. The last three are still a little bit harder. So I what I'm expecting today on the second snapshot is that those of you like on the top two, three rows who got like +1 or +2, I expect today to see you getting like +5 or 6. And then there will still be three challenging ones at the bottom that, again, might be where we pump the brakes a little bit. But I would imagine we're going to see vast improvement on the easy ones, the easier ones. So let's get started with this. And no need to shout out answers. I just want to give you all a chance to work them out. So you write these down, work them out. And this one again is pretty quick. So, all right. I imagine we're all done. There's two answers that make sense. One of them I could understand if someone put x to the second. I could also understand if someone put x to the sixth. If you put anything other than that, then we're having some pretty major communication issues, you and I. Which one of those is correct? X to the sixth is correct. Good job. This is the property, remember, where we take our power on top and our power on bottom and we subtract their exponents. 12 minus 6 is 6. So great job if you got that one. All right, how about this one? How about x to the fourth raised to the power of the ninth? We'll say again, I would expect one of two answers. Anything other than one of the two things I'm about to say would be pretty odd. So the first possibility is going to be x to the 36th power. And the other thing I could understand if you got would be this. Like I understand both of these answers, but only one of them is correct.
13.
I wish it were 13. It is 36. Remember that with this particular situation, when I have a power and I'm raising it up to a power, this is when I multiply my exponents together. And 4 times 9 is 36. Right? So there is a time to add exponents and there is a time to multiply exponents. This is the one where we multiply. All right. How about this one? How about m squared n to the eighth all to the third? By the way, I hope you all had a lovely Halloween. I hope you acquired lots of candy. Again, you should be done. These are not 2-minute problems. These are 10-second problems at the worst. So um, I'm not going to put multiple choices up here again. Who would like to volunteer what you think it is? Go ahead, Embry. M to the sixth and n to the 24th is correct. All right. So we're using two properties in a problem like this. The first, like the overriding property, is we're taking 3 and we're distributing it into everything inside. Remember that if I see your phones, I'm required by school policy to take them. So property number 1 is we distribute in, and then property 2 is subsequent to that. We have to know what we're doing with those stacked exponents. And that is back to the last problem where we multiply them together. So the 2 times 3 gave us the 6. The 8 times 3 gave us the 24. All right, the last of the basic properties is this one. Let's say we had y to the power of 8 times y to the power of 4. This is another one where if you get anything other than one of these, I would question where your heart is at. I can totally understand both answers, but my job is to try to get it so you don't have to decide between the two. It's not like a coin toss. Which one is correct? 12. Because when we have separated powers, note that this green thing and this yellow thing are their own entities. When you multiply two separated entities like that, that's when you add the exponents together. 8 plus 4 is 12. Therefore, this one is correct. This one is no bueno. Bless you. So those are the four basic properties. Make sure you should get all four of those correct on today's snapshot. So now they're going to get just a little bit harder, but not much. So we're going to have a couple problems where we're going to have a clump times a clump. So for an example of this, let's say we had like 5x y to the fourth times negative 6 x to the 10th y squared. It looks more difficult, but really it's not. It's more work, but that doesn't necessarily mean that something is harder. Again, you should probably be about done by now. What we're going to identify, oh, first off, who thinks they have the answer? Anybody want to read it? Go ahead. I like that you said negative 30. I'm going to start with that. I like that you did 5 times negative 6 and that you got negative 30. And honestly, I didn't quite hear what you said for your x's. No. Yes. How many x's are right there? It has an exponent of 1. And we know in this case to use the property that is adding them together because they are separated entities. This red jelly bean and this red jelly bean are not stacked powers. It is an entity times another entity. We know to add exponents when we're faced with that. Therefore, it is x to the power of 1 plus 10, which is 11. And for the y's, I have a y over here and a y over here. What will my y exponent be?
Right.
Done. And in your defense, like if you're saying that's confusing, I understand. I've seen this before. It's like we're adding exponents, but a common mistake I see is people take the green things and add them together, and that's just silly, right? I mean, still a multiplication problem for goodness sake. So how we treat base numbers, normal numbers, is different than how it feels like we're treating exponents. We arrive at our answers in different ways. Do you have any questions about that one? Okay, let's try that again. That one was a little bit rough. Let's do negative 2 m to the fourth n to the 12th times negative 3 m n. Done. Gunnar, would you like to volunteer?
6, 5,
I like that. I don't like the way you said it, but I do love your math. Let's all teach out of ourselves today, saying things like M10 and M5 and stuff like that. Those are like names of like, I don't know, fighter jet models or something, like the M10 fighter jet. When you're saying an exponent, you have to use the correct language. So you can say like M to the 5th and N to the 13th, but please stop saying like N13 because that N13 would look like this, and that's not what you want. Okay. So great math, good answer. Just let's clean up the verbiage. Does anyone have any questions about the last two problems? Okay, next one. Let's do negative 4 k to the 10th m to the fourth, all of it to the second. This would be the equivalent of problem 7 on today's little snapshot for the record. And then after this, we've got a couple fractiony ones, and then I'm not even going to probably go through the last ones. We're just going to see who's up to the challenge. So we have this and 2 more, and then I'll shut up and hand out some work. There are 3 airdrops here. So make sure you do all 3 airdrops. The first airdrop is the red one. So this exponent, the 2, says I'm going to be airdropped onto that number. That has an answer. The second airdrop is the 2 being dropped to this. And the third airdrop is right here. So you should have 3 parts to your answer, essentially. What's just the first part? Positive 16 all day long. Because when you take a -4 and you square it, go ahead and do the math as you go in a case like this. There's no negative exponents or anything to stop us, slow us down. So when I take a -4 and I square it, bless you, I get positive 16. So I'm going to write this in red. So positive 16. Nice. Now we're on to the green airdrop.
K to the 20th.
K to the 20th. Nice job. Way to go.
M to the 8th.
Nice. There you go. So we're using multiple properties with a problem like that. First, the distribution property where we know we need to airdrop in. And then the second one subsequent to that is when I got to know what to do with the exponents that I'm stacking. All right, the last 2 are going to be the fractiony ones. Can I scroll this off? May I? Okay. So the next one is going to look like this. 6x to the 4th, y to the 11th, over 8x, y to the 15th. Sorry for that big space. Why? Better. 3-step process. I'll color code them while you're working. There is a red step.
So that'd be division.
It's just reduction. It is division, you're right. But in a case like this, since you can't literally, or you don't want to divide 6 by 8 since it won't work, then we switch our brains over and we just say, I'm going to reduce the fraction. It is division, but since it's like if it was
3/4.
right. If it came out nicer, I would say let's divide, but when it doesn't, we switch to fraction reduce mode. So step 1 is the red. And again, while we learn exponents, we're inclined to do silly things like 6 minus 8. But we just got to coach that out of ourselves. At the end of the day, this is not a subtraction problem. It is a fraction, right? It's a division problem. So I'm going to build an answer over here. And like Seth told me just a little bit ago, I'm going to reduce the 6 and the 8 down to a 3 and a 4. That's not subtraction. That's not algebra. It's just reducing a fraction. How many x's are we going to get?
X to the 5th.
Nope.
4.
X to the 3rd is the right answer. Now let's take a look at why that is. The x on top has an exponent of 4. I'm circling it in purple for you. Does the x on bottom have an exponent? You just can't see it, but it's 1. And we know that when there's samesies top and bottom and we want to mash them together, there's a property for that. It says to do minus. So we're going to take the exponents, the 4, and we're going to go minus the 1, bless you, in that order, and we're going to get 3. So I am going to take x to the power of 3, and I'm going to put it on the top because it was positive. So x to the 3 goes on top. Rinse and repeat. Again, I will circle for you. The y on top has a power of 11. The y on bottom has a power of 15. And 11 minus 15 is a math problem that anyone past a certain grade level should know. It is -4. So I am going to put in a y to the power of 4, but because it was negative, trying to be negative, I'm going to put it on the bottom like this. Boom, boom, boom. I reduce the fraction, subtract these, done. Uno más. Got it? And then we'll work. I really want to see some vast improvements today, so I'm hoping for the best here. Let's do a -12 m n to the 12th over 6 m n to the 13th. I haven't said this before. The key is don't attack it all at once. Attack it in steps. Attack the fraction, and then attack your m's, and then attack your n's. Just place them in where they need to go. You're not unwise to just build your answer right now like this. Just make a line. Say, there's my answer. I'm just going to put some stuff in there. Someone tell me something. It's going to be negative something. Let's agree that there is exactly one negative number in this problem, and it's right there.
-3.
Spotlight on you. So I'm going to take a negative and put it right there. Just put it in it. You know the whole answer, no matter what, it's going to be negative, because if you find just one negative, he's going to infect everybody. So let's talk now about 12 and 6. What is 12 reduced down with 6?
To 66, which
2.
2/3.
12 divided by 6 is 2. If you want to be consistent, because now you're like, what the heck? A minute ago, you told me not to do division. You told me to reduce it like a fraction. If you want to always think in those terms, what can 12 and 6 both be divided by? 6. Leaving 12 divided by 6 is 2. 6 divided by 6 is 1. Like that. But I'm always going to green light myself to do an actual division problem when the numbers tell me that they can. You give me a 20 and a 4, I'm putting 5. You give me a 20 and a 12, and I'm putting 5/3. Like when I do division is different than when I do reduction. I do whichever one the math gods tell me to do. In this case, I knew that 12 could be divided by 6, so I just jumped ahead. And I will never put a 1 on the bottom like this. I mean, I just did, but I would, of course, erase it now, right? Because that's just weird. Tricky. Let's do the green box. Tell me
M to
about the
1.
green. They cancel out because there's an m to the 1 on top and an m to the 1 on bottom. And the last I checked, 1 minus 1 is a whole buttload of nothing. Therefore, those are just gone. No m's in your answer. Yes, sir. I don't know. Let's find out. Let's do the n's now. The exponents are 12 and 13. And what is 12 minus 13? -1, which means I'm inserting an n to the power of 1 on the bottom. Therefore, the answer is -2 over n. Done. Pieces, numbers, and then variables. Good. All right, I'm going to hand this out. Let's see if we can get some serious improvement today. I'm assuming you still have it. If you do, I would like you to, when you turn this one in, again, boys, you're not listening, so you're not going to hear this. I don't know what your deal is. I would like you to turn in not just this one, but also the first one so that I can see your improvement. I want to track your progress. Good? All right, let's do this.